Dear students, the topics that will be discussed in today's video are what is the state of a thermodynamic system? What do we mean by equilibrium state? What does this state postulate say? What are independent properties? What is a thermodynamic process, path, and cycle? And what are the various thermodynamic processes? So let's start. But before starting, can you tell me what is common in a jet engine, nozzle of a rocket, and a bicycle pump? Well, the answer is all of them are thermodynamic systems. Now, if I want to study a thermodynamic system, be it the jet engine or the bicycle pump or the nozzle of a rocket, first I have to define the state of the system. Now, what do I mean by state of a thermodynamic system? Well, let us consider a piston cylinder arrangement. We have a gas which is contained by the piston and the cylinder, and we select the gas to be our system. So basically, we want to study the gas. So this becomes our system. Now, definitely, the gas will be at some pressure, temperature, it will have some volume, right? It will have some internal energy, enthalpy. If we fix those quantities, let me say the pressure is P, whatever it could be, right? If you fix, let me say it is 10 bar, let me fix the temperature, let me say it is 300 Kelvin, right? Volume is, let me say, 100 ml or 1000 ml, whatever you want. We have internal energy, enthalpy, entropy. If we keep on fixing all these properties, then we arrive at a particular state of the system. So you can say we have a gas which is at a temperature 300 Kelvin, pressure 10 bar, volume 100 ml, and blah, 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 blah. Now, do you really need to specify all the properties to fix the state of the system? Because if you have to do so, if you have to determine all the properties, you have to state all the properties, it is going to be a very, very complex set of data. Every time while defining a system, you have to specify what is the pressure, temperature, volume, internal energy, enthalpy, entropy, density. Then we have the specific properties. So many things to be determined. So what to do? Here the state postulate comes to rescue. What it says, the state postulate. Now, before going to the state postulate, let us try to understand what exactly do I mean by equilibrium, right? Now, if all these properties are fixed, if it is not changing with time, with respect to time, right, then we can say the system is in the state of equilibrium. But if you have to every time monitor each and every property, it is going to be a very complex task, difficult task, and the subject won't be that very interesting. So here state postulate comes to rescue. It says that to define the equilibrium state of a simple compressible system, we'll try to understand that, we just need two independent intensive properties, just two. So if we just fixed any two properties which are independent and intensive, then the rest of all the properties gets fixed. You can think of it as a GPS system, right? If we fix the latitude and longitude, right, we pin down onto an exact location of Earth, exactly where you are sitting right now or where you are standing right now is defined by the latitude and longitude. Similarly, if we choose two independent properties, independent intensive properties, we pin down onto exact state of the gas. Yes, that's right. But I still have a confusion. Well, what do I mean by a compressible system, independent properties and intensive properties? Specifically this, what do I mean by independent properties? Let us try to understand this. Right? So what is a simple compressible system? A compressible system means which can be compressed, means the volume can decrease or increase, the volume can change basically, right? Without, and which is without any magnetic, electrical, gravitational surface tension effects. We can take air or the production of combustion as an example. Now, what are intensive properties? We have already seen it in our last video. It is the properties which do not depend on mass, not depend on mass. Example, temperature, pressure, specific volume, density. But our point of concern is, what are independent properties? What is this? What is this? What is this? Independent properties. Well, properties which are not dependent on each other are known as independent properties. What? How can the properties be dependent on each other? Well, let us take an example. Now, let us take this system of gas. Right? Now, it is at a certain temperature T1 and let me say it is at pressure P1. Now, suppose I heat the system, I supply some external heat into the system. As a result, what happens? The temperature T1 increases and it changes into T2. So, what do you think will happen to pressure? If I change the temperature, keeping the volume constant, the pressure will also change. It will increase and it will become P2. So what does it mean? It means that temperature and pressure are not independent properties, they are dependent properties. Why am I telling this? Because pressure and temperature, they are related by the ideal gas law. So you can see that P is equal to rho RT. So if I increase the temperature, the pressure is also going to increase. On the other hand, let me say I compress the gas, right? It was a temperature, it was a temperature T1, pressure P1, let me say the volume is V1, right? Now, without changing the temperature, I suppose compress the gas and the volume changes to say V2. Now, it is not necessary that both temperature and pressure will change to T2 and P2. Yes, one of them will change, but it is not necessary that both of them will change. I hope you're getting my point, right? So increasing in V2 need not necessarily increase T2 or P2. Any of one of them can definitely increase depending on what exactly which process you were trying to follow. So the basic understanding is that if suppose I have say nitrogen at a temperature 25 degrees centigrade and volume 8 meter cube per kg, right? To define the state of a nitrogen, we need two fixed independent and intensive properties, which can be given by temperature and volume, right? So temperature and volume becomes a good set of independent intensive properties. We can select pressure and volume, right? But we cannot select temperature and pressure. No. Right? So temperature and specific volume are independent intensive properties, whereas temperature and pressure are not independent, though intensive properties. They are intensive, but they are not independent with each other, right? Because they are related by P is equal to rho RT, the ideal gas law. Having understood this, let us try to understand what exactly is a thermodynamic process. Now, let me say I have a system which was initially at this point, right? The piston was at this point, right? So when it is at this point, let me say this is point 1. Right? Let me say it is somewhere here. So this is at V1 and the pressure is P1. Then I start compressing the system. So the pistons moves towards left. So as it moves towards left and it reaches say position 2. So when it moves towards left, right, what will happen? The system will change. The state of the system will slowly change and it will reach a point 2. At point 2, you can see the volume is V2 and the pressure is what? P2. So this was our initial state 1. This is our final state 2. Right? And this phenomenon, when the system, it moves from one state of equilibrium to another state of equilibrium, is known as thermodynamic process. And you can see it is following a path. You can clearly see this is the path of the process. Right? Let us try to define them. Any change that a system undergoes from one equilibrium to another equilibrium is called a process. So we went from the equilibrium state 1 to equilibrium state 2, and this is nothing else but a thermodynamic process. And the series of states through which the system passes during the process is nothing else but the thermodynamic path. So it has to pass through different states, 1, 1 dash, 2, 1 double dash, 1 triple dash, right? You have to go through many different points before reaching the final equilibrium point of 2, right? This is nothing else but the path. And then we can understand what is a cycle. Suppose the system, it goes from point 1, the state 1 to state 2 first, right? It went from 1 to 2, and by another process, it again returned back to point 1 from 2 to 1, such that the loop is closed. This is what a thermodynamic cycle is, right? So for a thermodynamic cycle, the initial and the final states are identical. So this was the initial state 1, and final state is also 1, because it did not stop at 2, it returned back to 1. Having understood this, let us try to understand what are the different thermodynamic processes. Now, usually we allow one of the properties to remain constant. This helps us in our study, and this helps us in these are all assumptions, by the way, right? Approximate assumptions that we keep one of the properties to be constant, but this helps us derive the equations, find out the work done, the heat transferred. All these basic principles are on this assumption that the processes at least one property remains constant. So we can identify 5 different processes, right? So we have the isothermal process where the temperature remains constant. We have isobaric process where the pressure remains constant. We have isochoric process where the volume remains constant. Isentropic process where the entropy remains constant. We have to study what is isentropic, or basically saying what is entropy. And isenthalpic process where the enthalpy remains constant, right? So these are the different thermodynamic processes that are possible. Thank you. See you in the next video.